Hey guys, welcome back to the channel. So in this video we'll be discussing more about biochemical and bioprocess engineering. So this is a further extension from the previous video. So if you haven't watched the previous video, you may refer to the previous video so that you can get the reference clearly. So moving on with this today's lesson. So today we'll be discussing about types of bioreactors and furthermore. So let's get started with this. So talking about different types of bioreactors, there are many types of bioreactors which comes into play, such as stirred tank bioreactor, airlift bioreactor, packed bed bioreactor, fluidized bed bioreactor, photo-bioreactor, membrane bioreactor, rotatory drum bioreactors, mist bioreactor. We'll be discussing about all of them in brief. So these bioreactors are the fundamental part of any biochemical reactions. So let's just get through into this. So talking about stirred tank bioreactors, so these may operate in these three types of modes, which can be batch, fed batch, or continuous. So I'll be explaining about all of these types in my coming videos in detail of what these operation modes mean and how are they different from each other. Alright, so in this stirred tank, as you can see, this is an agitation system that is very much essential for every bioreactor. This has a system monitor, this has a sensor probe, this has a thermal jacket which is prevalent for every bioreactor, and this has an effluent for release of waste substances, and this has a submerged aerator, and this has a reactor tank. This has stirrers, as you can see, for storing the mixtures, and it has the air input system from here, it has the medium input system from here, and it has the feed pump here, as you can see. So this is what the stirred tank looks like. This is the basic model of a stirred tank, and these may operate under batch, fed batch, or continuous modes. So moving on with, so their stirred tank bioreactors have different sort of impellers, propellers, or stirrers, as you can see. So this is the top view of a stirrer, as you can see, and this is the side view of a stirrer. All right. So there are different sort of impellers and propellers that are used in stirred tank bioreactors for mixing the mixture. All right. So this is how the combination of stirred tank reactor bioreactors look in real life. So moving on with, so we have the airlift bioreactor. So in this airlift bioreactor, so the air supplies from here. We have the riser region, from where the region gets uploaded or gets raised up through a air loop system it has, or an internal airlift system it has. That's why it's called an airlift bioreactor, and it has a region that moves circularly from up to down. As you can see, the arrows are moving here through the help of the air supply. Alright, so as you can see in this A, B, and C picture and D picture as well, so it has a, as you can see, air is there. As you can see, it has a proper air supply. With that, it regulates the bioreactor mixtures throughout in the system so that it can be mixed properly without the use of impellers, propellers, or stirrers. Alright, so this is what the airlift bioreactor means to us. And also there is an external loop airlift reactor as well, in which air is supplied by some medium which moves, which is not similar to the internal one, where in the we have a down corner, which is a different sort of diagram we have here. As you can see, these are both are not the same. As you can see, there are two shafts. As you can see, these are two shafts. As you can see, there is no shaft here. There's a big substance here, so around this the fluid revolves around. So moving on with this, we have this picture, in real life picture, the airlift reactor, how it looks like. So we are providing external air from here, as you can see, and it gets, the mixture gets uploaded or raised up with this system, as you can see. And also there are some more of the pictures. As you can see, as we put the liquid or the gas, so the this thing mixture gets rinsed up, and thus it gets mixed. So this is how it works. Non-compressing and compressing are two things. This is how this thing system works. So this is all about the airlift bio. Uh, all right. So this is a picture, as you can see. So this is this material, the packed bed thing, is coated with TiO2, titanium oxide cement beds. As you can see, a real life picture as well of a packed bed bioreactor. and how the reactants get inside, and it relates with this or mixes with this, and we get the product out of it. So moving on, so we have again fluidized bed bioreactor. So in this way, fluid is used, and some sort of fluid is used, which is which acts as a catalyst, or which acts as a region where the substances get interacts with each other, and thus we get the product. All right. So this is a lighter polymer catalyst, particles heavier polymer catalyst. So this is a mixture of all the um, catalyst polymers part where the reactants react, and thus we get it. So moving on with this, we have this again, the fluid bed at rest, and this is the fluid bed with gas flow. So these are two things that we can make out of this. So this fluid is consist of each catalyst particle is about the size of a grain of sand, and this the flow of gas. This is different. This is not about the sand. This is pretty much separated, as you can see. The flow of gas makes the catalyst particles behave like a fluid. All right. So as you can see, reactants, ethane, hydrogen, chloride, oxygen. As you can put in the reactant, and it combines with the reactants and reacts with the reactants, and thus we get the product as chloroethane. This is just an example for this type of reactants. We get this product. So moving on to this, we have this photoreactor. As you can see, works under sunlight. All right, so it reacts with the sunlight, rays of sunlight, and thus out of this. So this is a basic principle of the photoreactor. So this is the sunlight. This is the reactant, as you can see. All right, so this is the photobioreactor. All right, so it combines with carbon dioxide, and thus it releases oxygen with the help of algae, and from this we get the biomass. This is a basic diagram of a reactor. So coming up the another type of bioreactor, which is membrane bioreactor. So this is the membrane bioreactor, as you can see, with contains of the filtrate membrane that filters the parts, and thus we get the clean water around. And coming to the bigger part of this membrane reaction, which is the activated sludge treatment, which is the prominent part of wastewater treatment, in which we have the grid wastewater, we have the solid removal systems, we have the aeration system, we have the settler, we have the sand filtration effluent, or all of it. And we have the second part of the membrane, which is the membrane bioreactor process. So through which this wastewater gets inside this and this goes through a solid removal system, and it gets pre-treated so that the sludge or the wastewater gets removed, and thus it moves into the aeration zone where it is supplied with air, and thus we move to the membrane part where it's separated through the membrane. All the dust particles are removed with the help of membrane, and then it is disinfected for any sort of impurities, and thus we get the product out of that. So this is the input of effluent, and this is the output of effluent. So this is how this membrane bioreactor as well. And talking about the rotatory drum bioreactors, as you can see, this is a schematic diagram of a drum bioreactor. So this is the outer stationary drum one. So part one is the outer stationary drum, this part. The second part, which is the inner rotatory drum, as you can see, inner rotatory drum. Third part, which is these are the steam enzyme seized pH adjustment systems. All the temperature, pH adjustment system knobs are there. These are knobs. And the fourth part, which is the connection for product recovery. This is the product recovery system. And fifth part, which is the product condenser. This is the product condenser part, PC. And sixth part, which is the last part, which is the temperature and pH measuring. So these are two knobs or probes to be said. These are two probes for measurement of temperature and pH. So this is a better picture of a rotatory drum, as you can see in this real life. This is a picture for rotatory drum bioreactor. These drums are also these drums are perforated drums, and underneath we have the air inlet. Above we have the filling and the sampling door. Outside we have a air outlet. We have sliding doors and shaft for moving some parts. Alright, so here we have a label diagram along with these labelings, as you can see. So with this we have the mist bioreactor as well. So in this we have the air inlet. So it goes through the mist generator. So in this we all form the mist, and it moves through this small tunnel or chamber, and it prefers or it utilizes the plants to grow under this chamber with the help of generation of mist. So this is the mist generator, and this is air where the air gets inputted. So the mist generator and growth chamber, this whatever we have allowed here with the help of mist generator moves through this tunnel to form growth chamber. All right. So in this, as we put in air, we a lot of mist is produced, as you can see. So it moves through this part to form more of mist so that it prefers growth. Okay, so this is a better picture of a mist. All right, so these are two knobs, as you can see. These are, as you can see in this A part, so one of this is a mist generator, this big part is a mist generator, and from there this gets transferred into a smaller tube so that it prefers growth. As you can see, there are two chambers, one upon each other. So this is the mist generator, and from here all the mist gets transferred here to form growth. All right, so that was it for the types of bioreactors. Hope you like the video, and stay tuned for more, and thank you for watching this video.